Bismillahirrahmanirrahim. Assalamu alaikum everyone and greetings. Today uh, I will talk about the model fine tuning as well as exploring the quantization and transformer, and it's day 2 of Gamma Extended Day organized by Tufuko Bangladesh. Well, today I will try to cover what is fine tuning, how quantization reduce the size, and we also see the LoRa configuration, and finally we will see our the GEMM-2B Leon model, how we download it from Hugging Face to in our local Kula. Well, first of all, what does mean model fine tuning? Why do you need? Well, before theoretical start, I just want to start from a basic story. Like we can see that there is a huge gold bar, but we cannot do anything like with this. We cannot use it without any specification what we want to actually do. In the second picture we can see that ring. So we want to make a gold ring from this gold bar, so we have to follow the specific procedures or set of protocol how to make a ring from the gold bar. Then we will find a gold ring. Though everyone has perspective view different, so they can make anything what they want from this gold bar. As like in the model, it initially the base model train a number of parameters, and the token it, it start from the basic um, web article to medical text and so on so forth. Everyone like a finance committee has no need to the medical data, so he just uh, fine tune. We can also say that he just extract particular information from the base model as he get more better output. And okay, we'll start from our hands-on note. So well, so okay, first of all what I have to show, well, so assume that this is our base model. Already I told that it trained a lot of token. For example, Google Gamma 2 billion model is almost 6 trillion, probably, maybe I'm wrong, that or 6 billion token train the model. So can you imagine that how many information it collect all sort of information. So what do we do? Or for basic understanding what does mean the basic, just consider the GPT model. So in the GPT model we saw that and we first to introduce with the one model is chatbot like chat GPT. So this is the great example of fine tuning. From this base tuning we can also create a chatbot. Okay, not only that, we can also domain specific, which means that if we fine tune like uh, a, so domain specific means what, well, the domain specific refers the thing like someone want to chatbot create for banking management system, like someone create to deposit account or what the information need, all things just banking related information it can provide. The finance chatbot. uh, on the other hand, if we consider the medical um, assistant chatbot, they do not need the information about the history, sociology, or civics, but it can particularly train on this domain. So uh, so we can see that in to the fine tuning, we can create any domain specific tags. So when the terms fine tuning come, here is the one of the important term will also associate with it. The strongly connection word is how the size is reduced. We never download the base model in our end devices. Yes, we can download it if we have a number of GPU. So this is not possible to buy a number of GPU, as there is a money concern, and so it's possible to run in the cloud. So it, but we want to show the how the model works or how it perform well in the end devices. That's why quantization help us. So we saw something about quantization. Okay, so to write about something. So before we go to the definition, we want to I also mentioned the one thing that in the any generative model, or you can say deep learning or machine learning model, they know everything about in terms of math. They do not understand the any particular type in text, like whatever the text it convert to a number. So the numbers stored in two way. Basically the one is float value bit 32. We all know that how the 32 bit works, and another one is integer 8 bit. uh, the floating value itself has three version, like f16 and bf16, which means by b means binary or brain something. I cannot remember fully, so sorry for that. So for each cell, we know that how the matrix, the weight stored in a matrix. Okay, so each cell required 32 bytes, which 4 bytes, 32 bits, sorry, 4 bytes and 32 bit each cell require. So assume that if we have like the matrix size bigger, we need the bigger size of memory. So compared to the 32 to 8 bit, we can see that as the size is reduced, we will lose very few accuracy here. So the fine tuning means or quantization help here to reduce the size from 32 bit to integer 8 bit. We can also convert it in 4 int 2, but this is generally, if we try, we can do that, but in our gamma 2 model we will load this in 4 bits. So just want to we know that how the bit representation work. We can see the first by default as the value, each cell has float 32, so we can see that here 32 bit, and the first bit represent the sign bit, either is positive or negative number, and then the letter x 8 bit, it means exponent, and the letter 23 bit represent the fraction bit. So whenever we convert to the f16, it also named the half precision. So whenever we want to convert 32 to 16, we can see that the exponent bit also reduced by 3, as well as the fraction. And in the integer 8 value, we see that the first one is for sign bit, and the later 7 bit are for what I say, the exponent bit. Okay, so now if I want to tell the definition of quantization, it converts the higher memory to lower memory. Why? Because we already mentioned this thing, that the as large model it needs number of GPUs for the fit model, just fit the model, not train. So as day by day the LLM model, every day born new LLM model, as well as its the token size is grow. So the more grow token size train in the training time, the model perform very well. So here the quantization technique help us to this model run in our end devices for perspective of fine tuning. So two type of quantization, one is PTQ and another is uh, QAT. So this is all behind math, everything in deep learning, all whatever we want to do, math and matrix multiplication or matrix decomposition. Don't worry, we will not deep dive into the more, just mention it the two term. PTQ refers the post training quantization, that means after base model train we can train these, as well as the QAT represent the quantization aware training during the training and it's after the training. So it's time to see how quantization actually work. Okay, so let's do that. First of all, I draw a basic architecture of neural network, and everywhere we need this network. If we also run the deep learning model after convolution layer or residual block, in the final FC block we pass this all the information in the uh, neural network, and then we will get the desired output most of the cases. So weight, where the weight represent, this is the connecting path between like this. If I refer the node number 1 and 4, so the connecting value is called weight, and initially it's randomly initialized, and after the training and break propagation the weight fits, and the the more weight fit, the less of model we find the loss accuracy. So this weight, how do you show or represent? For understanding, I just draw 3 to 3 shape matrix. So this is our 3D matrix. So this like 30.6, all are floating below, and so on, like this. So each cell, or each cell, it has 32 bits or 32 byte, 4 bytes. I just conflict the between what bits and byte. Okay, so if we calculate the 4 into 9, it requires 36 bytes. If we calculate into the 8, we also convert this into the bit. Okay, I know that you have the proper idea about this. So we see that this matrix need 36 bytes. So what happened if we convert this into integer 8? So we know that integer 8, what it means, that the basically it store value from 0 to 55. If we consider the unsigned value, means all the positive consider here. So like in the previous page we see that there has 30.2. So for simple understanding, just consider it here, it is stored as like 30. So we know that here the each value is stored as a I mean what I say, which value stored as binary. So definitely when with the binary conversion 32.1 to float to integer, so the binary calculation is different. We consider this simple mathematics as for easily understand. So we know that whenever we consider the int value from a floating value, we ignore the fraction, and they need one byte, okay, or 8 bit, as we reduce the size. So here 9 into 1 is required only 9 bytes. Just the 3 into 3 2 matrix in the floating value requires for 36 bytes, where it requires one fold of 9 bytes only. So we can see that how the size reduce whenever we convert to 32. Don't worry, I will also show in the model how the size also reduce from the quantization. So in the earlier I mentioned it two terms, that the two type of quantization. Also there are how do you perform quantization, like how do perform quantization? Well, there are two approaches, symmetric and asymmetric approach. Okay, so if we understand one, we will also understand the other one, and there are also the two term need. One need is a scale and another need is 0 reference point. So in the symmetric, we consider all the numbers here stored as a positive, like 0 to we have 1000 floating value, all are floating. Okay, so we want to convert this into our, for simple, just consider this the value like floating value, and we convert this range to this range. So how do we convert this, or what will help us to reduce it? Well, first of all we have to find the scale. I mean, uh, if we find the scale and divide from the scale value, we will see that the value will uh, reduce and fit for this range, like how it is. For example, I also mentioned that I just rewrite it again here, and here the value, our, this is our quantization limit, okay, and this is our actual value. So how do you find the scalar fraction? Okay, so if we minimum, actual maximum divided minimum, and quantization maximum divided minimum, then what we will find, if we will find 3.8 plus something. Okay, so if you round this value, so why, what we will find 4. So okay, so just we pick a random value from here, like the 64. So if we divide this value 64 divided the scale fraction 4, we will find 16. So uh, so you can have a little idea that how 64 are stored as a reference of 16 in the quantization limit. Okay, so in the asymmetric, what will happen? Well, in the asymmetric, just considers the previous one, same example here, just only the minimum start from negative values, and as well as my quantization limit is 255. So what I have to do here, similarly if I calculate the friction, I will if I round this, I will find the 4 value. So the other term I also mentioned it, that is the 0 reference. So how do it works here? Well, we see that our quantization limit between 0 to 55. So how do we fit a negative value from this line? Well, if we consider the minus 20 divided by, okay, sorry for that. Okay, we know that our scale value is 4. So if we divided this minus 20 divided by scale fraction, so we will find minus 5. So as our limitation between 0 to 255, so how do you store negative 5 here? Is it possible to store? In general cases, no, but if we add the similar positive number, we can store it here. Okay, so this is the called zero reference or 0 point, which means we can simply say that the if we add the similar value with the negative value, we can add into the quantization limit. Okay, just I will back again theory after I want to show that the tokenization. I also mentioned it that how tokenization work or what it is. Well, so first of all, whenever we pass any sentence in the model like this, okay, I wrote a sentence here. Okay, just as it is the basis. So what does means token means that it's separated uh, and singular word, or we can say we can um, like indexing 0 2 3 3 each convert into one and it pass into the model. So I set the id or index 0 1 2 3. Actually it doesn't change the value, we can see here. Oh, sorry for that. So how tokenization perform? Well, uh, tokenization perform from the BART model. With help of BART model we can tokenize. So what does mean BART model? Bidirectional encoder representation. So simply to say that we convert this token into number as well as numbers. If we decode this, we will find the actual one after the sum processing. So the BART model has 12 layer and 12 layer of transfer encoder. I know that you have the idea about the transfer architecture, and based on the transfer model, every transfer algorithm or GPT algorithm develop or LLM also strongly based on the transfer architecture. So what do we do here? In the each sentence starting we add, I will explain one by one, don't worry. After tokenize we will add two sentences, CLS and SEP, which means separate, and I think that refers the close token probably. Why do you add this? uh, in the add this which represent this is the starting of a new sentence and this is the separate from the other one. That's why each sentence we add this for model understanding that the sentence is different from the previous sentence. Okay, and so why do we do here? We install the transformer if we have it, it's okay, and then we initialize the model BART model from pre-trained. We can see that there are a number of different type of model here in the BART model. We just consider the pre-trained BART based in case, and also we refer a sentence. I select a sentence that today is Friday, also called day Friday, as today is Saturday. The consider is this is just a sentence. So if we pass this BART tokenization, and that I also here the term is similar like BART tokenizer and BART model. We assign here model and here we assign the tokenization. Okay, and the token is a variable where we pass our the sentence, and after the sentence passing we can see that it converted into single word. Like if we feed this, okay, what's going on? Okay, we can feed this, will show a array here, but it doesn't work like this is the array. So here for visual understanding it appears one by one. So the length of token, which means that where the actual how many word are there, we can see that there it converted into 11th. And as the model required two token like CLS and separate things, so we add this before the token, and so we print this. We can see that I want to just show like this before one. If we ignore this CLS and separate, we can see that this is the similar. And then what we do, if we print this, uh, we will show the 13. And we also need the two additional padding. So don't worry, why do you padding add just for the like in terms of the image, the filter connection move like this, the filter each time 3 to 3 move. So if we have, if we add the zero padding, which means that extra zero row and column, so here without we lose information, that's why we can add padding here. And we just attention marks, so we know that the attention where comes from. The attention make the transformer architecture so vast popular in today's LLM world. And here we can see this is the just basic one line. I just set one if this is not paired, as we know the padding means 0, and otherwise we set 1. And if we print the token ID, convert into token ID like this, uh, just for example this one come first, this second, and the following one. So we cannot set 1 2 3, model cannot assign that model. We can follow the token ID, we can see that randomly 101 here, 102 at the end. We can see some value cross 10,000. Okay, so if uh, if we decode this token, we will find the actual the word. So inside the model it pass this token ID, and that match the conversation like following the prediction next word, like this is simple, then just ignore this, there is nothing. So what will be the next word, it can predict from for the like what I say, based on the probability which is the close, like this is simple cat. If we just consider, so the next word predict, so in our the sentence, uh, so this is the pass like this. If we decode this token ID, here I just show that how the convert the say a sentence into token to token ID, and then if we decode the token ID, we will find this. And here we can see that we ignore the special cases. Okay, so if we do not ignore, so what I will show, I will show that these two things also add like this special character. So ignoring this, so I just finally find what was the initial my sentence is. Okay, I hope you got some idea about how the sentence convert into token. So if you do not if you have idea, that's well. So what I say here, this is the quantization. I just pick a model, this could I collect from the deep learning.ai. This is also Hugging Face code snippet, so credit goes to them. So uh, at first I have to download this library, and specifically I have mentioned the version name. Okay, so T5 Flown model is also developed by Google. So one thing I have to mention that, so we just name this name, that's Google Fluent Mail. So how do you find it or where? So I have to tell a little about the Hugging Face, where every what it is actually, you can like call that the GitHub of I mean, just for understanding, we can say that the GitHub of NLP model. So here NLP, we know that what does it mean. Basically every model that are the transfer or LLM model we can find here, and this is the open source. Every organization post their model here, and so if we download any model, we have to, what we have to need, we have to need an at first a account, and if we go to the setting and in the access token, so this token is very important for us. So you can also generate new token, more than one token. So this token will help us to download a model from here, and in this interface we can see that. So the trending model, we know that the yesterday meta meta exposed their the latest model LLM3, so which has three version. We can see that there are many things we can find. So like this here we use Google Tree Small just for easy understanding that how quantization reduce the size. If I just search this model name, it uh, pick to me the site of Hugging Face. So if you want to know more about the model, you can see that here. Okay, also we can see that there is the code. So one thing, if you running in your mind that if they write all the code, so why do you need fine tune? Okay, the answer is simple, like they develop base model, they don't know what purpose you use. You are medical student or you are finance or you just want to develop chatbot, they don't know actually. So if you want to develop your own assistant from this model, that's why you need fine tune, you customize the model from your perspective. So that's the important of fine tuning. So here we can download the T5 tokenizer. Clearly the one thing is that in the transformer it is a library which is, we can say, the different model needs different tokenizer and the condition gener. So we need here T5 as our model is T5, so we need T5 method from the transformer. In the later when we go to the gamma b, we can show that the different name we can input from the transformer. So don't be panic, don't be remember everything will be find in the site, like what we have to do or what should we do, the code are given there. So I just insert hello my name is in the input text, and if I pass to the model generate, and this code is the return the size of model. So that is there is no things that understand like how many size of the model. So at first of that uh, I pass initialize the model. Okay, so what was the size of the initial model? If I run this model, this method is here mentioned. So if I pass this model here, we know that the model size is 0.3078 GB. Okay, this is too small. You can say that, wow, I have 15 GB free Google Colab, so why do you well, just for simple understanding that how the size reduce after the quantization apply. If we print the model architecture, so one thing is say that in the layer 0 the self attention, so we know that the q means query key, v represent the value, all are represent in the vector here. So before apply the quantization, we see that here the layer name is linear. So okay, so this is the layer. So we want to model the quantize 8-bit precision, so this is the default 32-bit model. Okay, there is no mention it. So by default model are 32. So we first of all quanto which help us quantize the model, and we set this is the torch int. We mentioned it, the weight are uh, data type convert. We want to show the integer 8 from F32 and activation none. So if I go back the previous model, okay, in the neural architecture, the things we need is here the weight and activation works here. If there are different type of activation like sigmoid, relu, or there are so many. One specifically the two things use sigmoid and relu famous. So whenever we pass the value inside the node, it will be output or no, like the 1 or 0. 1 means the it will be okay or no. So it's defined the activation. So in here we do not apply activation. I forget to mention that we can quantize both weights and activation. Okay, so um, we apply the quantize, and if we now print the model, so we can see the what the change. If we will follow the layer 1, you see that before the word linear add q, which means that quantize the layer. Okay, so the performance will not degrade. If we fine tune very less, performance decrease, otherwise no performance going to decrease. So after quantize we freeze the model, and we if we print the size model, so what we see 0.12, approximately 50% reduce. Okay, so that's the things main why I show the code to you, that how actually it works. Okay, so okay, it worked. Current access. Okay, so I already well, this is the code of Gemma, that is our main target today's fine tuning, how the fine tuning work here. So it means that the secret token didn't pass. Okay, I run interval, I close other cell. Okay, so how do you set our token? As token is very sensitive and everyone has unique token, so we do not share with my token with others. That's why we can set in the secret secret option. So here we set the token name like, and the value we find, I already show you how do we find the token. I just again show you the token is similar like this. Okay, so without token we cannot do. So here first of all I download all of my request library what I have need. uh, the bits and byte, it is here means that uh, what we show that is used for quantization, like if our as our model value set in the default floating 32, we want to convert it into the binary. So bit and byte we mentioned it, this term, this will help Gamma to quantize model. And FPT, which is the parameter efficient, and the parameter efficient, it has also different versions. So among them we just use LoRa. The LoRa means that low rank adaptation. I will show that how it works, don't worry. So okay, I just install all of the requires library, and then we also install the transformer. It's provide the API of a model that we can quickly download. And so I import this the necessary thing from the transformer. I use tokenizer, auto model, focus, LM, bit byte configuration, and gamma tokenizer. In the I close the file so I cannot see. Whenever we use the T5 model, we T5 dataset, we use T5 tokenizer here. So I mentioned it that the different is different. So I here I set my token. So if I want to len of this token, so probably I am sure that you will return 37, something like that. Yes, 37 size. So this is the configuration bit and byte. So our model ID, which means that gamma 2 billion, as it is, if you just search this model here, it will show the Hugging Face page here. Okay, we go here and we see this is the model. So my name is Teban, and we can also see the text generation, how it works in the API. Okay, so we also see the JSON output. If we visit this site, like the official user face of Hugging Face, it will show the many things, how we can uh, tokenizer, then model initialize, and then how we set the input. And here we see that the return tensor is pt, which means that PyTorch. And yeah, they mention it, if you use I also told you that the special version of floating is b float 16. So we can see that float 16, b float 16, and the above one surely. Oh, f32 is default, so they do not show that the conversion. So we can use p4. And so in the input, and we will show the output, how they also mentioned this. And here we can see the comparison benchmark result. Okay, if you visit this site, you will also so many things, and you will also so many uh, familiar with so many terms. So I heard the load in 4 bit, I by default it is false, I set up true. And nf4, which means I convert into the 4 bit, and the floating value 16 to 4 bit. So this is the code. If I have uh, like thousands weight, this is not part of this model, just I want to show that how we convert. Already we show the quantization, how memory 0.37 GB to 0.12 GB. So here we can see that if you the convert this uh, just 1000 weight, it need 35 100 bytes. So in our model, definitely it has billions of weight. So how many models are required for that? So well, if I run this model too many times, that's why I am getting this error here. Okay, don't worry, I will fix this and share with you. Okay, the issue I faced here, in sometimes in cases we will face this value because of I ran so many uh, code within our in this same account. That's why the version will change. So what I have to do, I just change the account, and I here I uh, run the same thing, where I from find this, I set the secret value here, and that's why I find this. And I mentioned this and this. Okay, we can see that after model, we pass also the model ID, and the must we have to pass the token. So we in the setup rules, they told us they agree. And then we pass this, we configured like bnb configured, where we mentioned it here. And this is download all of the things. Okay, and so what we have to see here, like imagination is more. So I want to show you one thing that I okay. So uh, we just like right here the change sentence, the change maker is bd learning. So if I run this, then what I will show, that I will show that it generate the text. Okay, it will take time because of the training is running. I will also describe what's happening there. Don't worry. Don't be panic about that. Okay, I have to wait for this. Okay, then I will back to the text hour. So depth sense maker is a PD learning platform, which is platform for all students to learn and grow. Author depth change maker. So this is the unique text. I'm sure that they never show the this text in their running time. Okay, so if we had the max new token 20, just like if I say it is 100, what will be the output will change we want to show. This is the model. We do not tra train with our specific data set. So before data set we want to show the magically things we can show that just it can returns everything. Those arms link are broken, but she tried to give us. So if I paint here makes token more than 100, it also give me the so many things. So I hope you will show that if we change the token number, we also see the output number is change. Okay, so you are want to know that if we pass this text, so how do we find this? Well, don't worry. So I will show you where from this quota and the author name. And here you can see that this is false. I don't know. I know that weight and bias, which means that disabled, and it's set up false, and the LoRa config. So uh, we mapping our data here actually in the inside. So train first of all we configure the LoRa. Why do we need the LoRa configuration? And we set the value r. So the in our fine tuning, the basically the work is we change the parameter as well as we can show the parameter is also the change. So you can pass any value here basically, but be careful about that, must be matured, you cannot initialize randomly. And we load a data set. So where do you find the data set? Again we go to the we in our fine tuning model we load this model with this data set. So I go there again and I search it. Okay, I find this. Well, this is the entire data set where we can see the code training and tag. Basically if we pass any sentence which writer wrote this code, the model return us. So like our chatbot is like this. The task is if we send any sentence, we can find that who will be the author. So if we visit the viewer mode, we can show the mode. Okay, I just randomly select this one, and I want to pass here that I want to show that actually it is work or not. Okay, so if I run this cell, so what I have to see now, okay, it returns the tag and source Harry Potter category. Okay, I just want to see that actually who is the okay, sometimes they can return wrong thing. So as the model is not well performed, learn well, I oh, okay, uh, I just change this sentence to this, like I want to see. Okay, after training we will also see that how the model perform well. Okay, so if I pass the 30, it try to generate something. So this is my bed. So if I pass here like this, I want to see that will it return the checks or author name or not. Yes, we can find that it actually return this the author name. Okay, we can want to test like this one. Nicholas Camford. Sometimes we find that it cannot return the actual name. Okay, so why do we need the LoRa configuration? Well, the interesting things is I am going to share with you that initially our weight is like this. Okay, just for basic understanding, this is the our initial weight analysis like this. So we can represent this, and if we see any LoRa configuration equation, we can find that the equation is like this, A and B. So what come A and B, I will show that the terms. I know that you are familiar with matrix decomposition. If you not, don't worry, I will try to explain as easy as like this. So how this convert into two matrix, one is column and another is row matrix. Okay, so we can see that definitely the size is this less than competition from this matrix, and we know that the size of this matrix 1 3, and we know if we have the two sides, how do you find the matrix? If we want to multiply this, definitely it can multiply, as we know that if the first matrix column equal to the next matrix row, then we can multiply. If we multiply this, assume that this is A and this is B. So if we multiply this, we will find AB, and the size of the matrix 3 into 3. So basically LoRa configuration work here like this, and here also the one term is the rank matrix. So I know that the 3 into 3 matrix rank basically 1. So this is also a mathematical broad topic, how do you find a matrix rank? So you do not go there. Just I want to mention that actually what LoRa configuration impact in the model. So as we are running this model in our end devices, that's why it can uh, LoRa configuration help us to perform well, to reduce the quantization. So okay, where I was this okay, so I load the dataset. Where I load, I also show this dataset, and if I print from the dataset, that will return. And if I uh, want to from the dataset like this will also return me the all the author name. So I hope you will understand that this is the whole. And okay, so we just move. And so where in the trainer we also configure the trainer. So trainer, the model and the data set what we have the train, and we pass uh, well, this is the actually fine tuning means that we can change this parameter based on um, our tasks and the goal. So we mentioned it that here we want SFT, which means that supervised fine tuning. So why supervised? We know that in the supervised model it has trained data as well as the what it has also the label. So if whenever it the trained data, it label is the author name. So that's why we use this. And we set maximum step 100. So I just want to, for short timekeeping, I just want to set 20. And learning rate we set this. And so okay, I run this this is do not take. So in the earlier it has 100 max step. So the more you set it, train the number of epoch. Simply we can set the loop n value set. So if we run this, and we can say that there is only 20 step. Okay, so we can see that the training reduce, also the fluctuate it. Okay, so finally we show that after it stop 20, if we set here 100, it runs 100 times. So it shows that the others configuration value. And if we pass this text here, now I want to know that the author name. Okay, if I pass the next token is 100, and it will not return me anything. Okay, similarly I also run this. Okay, I just want to copy from, though it is supervisors learning, I just copy from this here. Okay, I do not need to show you already. JK rolling, and what it returns, yes, exactly, it returns the author name. Okay, so this all about the fine-tuning of gamma 2 model. I just summarize entire the whole thing. So first of all, I download this library, and sometimes the error, if you find this, whenever if you run multiple model together inside the same model, you can face this. You will solve, we can change the account, and I saw that you will work well. So BNB4, which means that we want to convert the weight into 4-bit, and here we load our the model and tokenizer. Also we can set our access token for Hugging Face, and here we mentioned our dataset. We can load any dataset from the Kaggle and set here, and we will show the output how it change. And this is the training. If we set max step more, like this is the number of epochs, how many the train loop running. So if you set here the any number, it run the number, and if we pass this, we show that it can perfectly predict this. That's all about the gamma 2 and thank you.